Welcome to Ionic Names with Roman numerals. Remember, let's go over some Roman numerals here first. So 1 looks like an I, 2 looks like a double I, 3 is a triple I. Remember, there's no I in team. 4 looks like IV, 5 is a V, 6 is like a V1, 7 is like a V2. So those are your Roman numerals you need to be familiar with. 8 would be like V3, but we don't need to know it for this. So how do you know if a metal has a Roman numeral or not? Well, first of all, Group 1, the alkali metals, they're never going to have a Roman numeral. Group 2, the alkaline earth metals, they're not going to have a Roman numeral. As we go along and you learn, aluminum won't, gallium won't, silver won't. What are some of the other common ones? Zinc won't have a Roman numeral. But basically, if it's not in group 1 or group 2, if it's not aluminum, silver, zinc, then you need to look at your ion table and figure it out. And remember, metals are to the left of this zigzag line as it goes across. So basically, if it's a transition metal, if it's in the D block and kind of the metal part of the P block, you need to look at your ion table and see if it's one of these metals that can have a multiple charge. Now, when you're given the name and you're writing the formula, you're not going to have to worry about figuring out if it has a Roman numeral, because the name you're given should be correct and it'll already have the Roman numeral in it. So let's look at an example. Let's say you had lead 2 chloride. Now, we name this just like anything else. So you're going to look on your ion sheet and you need to find lead 2. And lead has a symbol of Pb. And then this Roman numeral, the 2 means that the lead has a charge. Oops, I moved that up. Had a charge of +2. That's what the Roman numeral tells you. It tells you what the charge is for that metal ion. Chloride, we look, is -1. So we have +2, we have -1, more positive than negative. So how many chlorides do we need to cancel out this +2? So what times -1 will give us 2? And that's 2, so we need 2 chlorides. So our final formula is PbCl2, right? Let's look at another example. In this example, we have manganese 4 sulfide, right? Because this Roman numeral IV is 4. So the symbol for manganese is Mn. The Roman numeral 4 means it's +4. Sulfide, symbol for sulfide is S, and that's got a charge of -2. So we have a +4 and we have a -2. And that's got to equal 0. So how many sulfides do we need to cancel out this +4? Well, we need a -4. So 2 times -2 would give us -4. So we need 2 of those. So our formula is going to be MnS2. And this would be manganese 4 sulfide. Let's look at one last example. Copper, Roman numeral 1 oxide. So copper, the symbol is Cu. The Roman numeral 1 means it's +1. Oxide is O, -2. So we got a total charge of -2. Copper is +1. So how many coppers do we need? A +2 to cancel out this -2. So how many coppers do we need to do that? Well, we need 2 coppers. So this will add up to +2. That's -2. That equals 0. And I've kind of done each of these a little different way, and hopefully one of these ways will stick with you and make sense so that you can come up with the correct formulas. So we have 2 coppers and we have 1 oxide. Here's our final formula. So really, when you're given the name and the Roman numeral, it's not that difficult. You just need to remember that the Roman numeral tells you the charge. So you can look on your ion sheet and it will say copper 1, it will give you Cu +1. But really, if you know the symbol and you know the Roman numerals, you don't need to look at your ion table because it's just copper +1.